Okay, take, what is this, 27? Alright, roll it.
Hi everybody, my name is Esmeralda, but you can just call me Ezzy.
And my name's Nick, but you can just call me Batman.
Are you serious? Batman?
Yeah, sure. Batman.
Seriously. Okay then, Nick.
Batman.
Okay then, Batman. Today, we're going to be watching a video clip on how to graph exponential functions.
Yes, on how to... Wait a minute, you told me we were going to be watching Jersey Shore.
No, Nick. By using multiplicative and additive manipulations, we're going to see how the graph of e to the x can be transformed.
Oh boy.
Roll the clip, Nick.
Batman.
22 is
So,
f of x equals 7
Is that like the graph or whatever?
No, Nick. That's a tacky Hawaiian shirt.
How might you go about actually drawing the graph of 7 minus 3 e to the x? You could create a t-chart. What is this for x equals minus 1, but that's 7 minus 3 over e. You could use your calculator to produce some numbers.
Is this guy serious? A calculator? We don't even have hands.
That's not the point, Nick.
But let's look at it from this perspective. Beginning with the graph of e to the x.
This is not the graph of y equals e to the x. This is actually the graph of the natural log of x. Now, this is an opportune time to point out the relationship between y equals e to the x and y equals ln of x. They are inverses. Just imagine the line y equals x and reflect the graph he has drawn about it. And voila! You have the graph of y equals e to the x. Are you sleeping?
What? Inverses?
You were sleeping!
No, I wasn't. Batman.
If this is the graph of e to the x, what does the graph of minus e to the x look like? If you produce the graph of minus e to the x, notice that it is the reflection of the graph e to the x across the x-axis. Question?
Isn't that
You're absolutely right. This is log, I want e to the x. Sorry. That is the natural log the way I drew it. This is y equals e to the x. Okay. And y equals minus, what I said is correct, is as long as I get a good picture correct. This is y equals minus e to the x. It's simply a reflection of the graph across the x-axis like this. Y equals 3 e to the x takes each of these terms and multiplies by a factor of 3. So you multiply this expression by a scale factor of 3. 1 goes up to 3, this number is multiplied by 3, and so y equals 3 e to the x has this form. And reflecting it across the axis, this again is multiplied by a factor of 3. It has this form down below. Y equals minus 3 e to the x. So here's the basic principle. If this is y equals e to the x, 3 times it multiplies each value by a scale factor of 3. Reflecting it across the x-axis changes the corresponding sign.
So notice that all the changes made to the graph of this function are done vertically. Think of the y-axis as your output, or f of x, and your x-axis as the input.
7 minus 3 e to the x then begins with this graph and raises it up 7 units. Right? So I can rewrite this as the graph minus 3 e to the x plus 7. which means I just take the scale factor and shift it up 7 units, get the corresponding value. This is 7 minus 3e to the x, is that basic shape. Notice it should be a little higher, but like for example, at x equals 0, this is 1, so this is 7 minus 3, which is 4, so at x equals 0, it's up to 4, but that is the basic shape of 7 minus 3 e to the x. Start off with e to the x, multiply it by a scale factor of 3, reflect it across the x-axis, raise it up 7 units is what this graph looks like.
When we add or multiply the function, the output will change. That is why all the action occurs up and down, unless you are manipulating the exponent. Then the changes occur horizontally, or the input is changing. Did you get all that, Nick?
Oh, yeah, I mean, I like my action vertical or horizontal. Did you get that?
Yeah. Yeah, I get it.
You saw where I was going with that?
Yeah, I got it, Nick.
Okay.
They read the good book from Friday till Monday. That's how the weekend goes. I've got a dream house I'll build there one day, with picket fence and rambling rose.
I feel so welcome each time that I return, that my happy heart keeps laughing like a clown.
Like a clown, I love those dear hearts and gentle people
who live and love in my hometown.
in my hometown. Those dear hearts and gentle people who live in my hometown.
So you're not really good at this improv, are you?